uh, what actually happens when you have a compound which is unsaturated,
Hmm.
I would say unsaturated, or compound with multiple bonds.
Okay.
All right, either double bond or triple bond. Not necessarily between carbon and carbon. It can be between any two atoms, like
Hmm.
carbon, 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 oxygen, and carbon, nitrogen. Preferably these three. All right, and there is a reason behind that. So when you have a multiple bond like this, as you can see in this last line of this slide, so any of these bonds are present, so they are capable of exhibiting electromagnetic effect. So
Okay.
what happens in electromagnetic effect? Uh, because out of these multiple bonds, double bond or triple bond, there is one pi bond is present in them. All
Yes.
right. I remember that you said sigma bonds move. Sigma bonds never move. All right. The pi bonds will move.
Okay.
So if I say, uh, talk about like this kind of molecule, you say this is, so out of these two bonds, one is sigma, the other one is pi.
Yes.
All right. So not necessarily if I've written sigma is a downward, so you should also say downward. One of them is sigma, the other one is pi.
It's fine.
So is a movement of pi electrons, not sigma electrons. All right. And
Yes.
this happens when you have a group coming in to attack the molecule. So if you have this molecule and this force is a problem. Plus, say example, if I bring H plus, all right, or say example, if I bring OH minus, or say Cn minus for a moment. So incoming group attacking reagent is either positively charged or negatively charged.
Yeah, okay.
If it is positively charged, it is called electrophile. You know the meaning of electrophile?
Yeah, that the one which uh, gain electrons.
No, no, yeah, which gains electron or which is electron deficient.
Yeah.
This is electron deficient. All right. So it seeks for electrons, right?
Mm.
And the other one is minus, which is nucleophile.
Yeah.
This is electrophile, and this is nucleophile. So whether it is nucleophile or electrophile, whenever these agents come close to such compounds in which you have C double bond C or C double bond O or triple bond N, or whatever, C double bond N would also do. So the presence of this attacking reagent, the electrons, pi electrons shift from one to another atom.
Okay.
If it is carbon's double bond carbon, as I said, the first example, then whether this electron moves this side or whether it moves this side doesn't make difference, because both atoms are carbon. It
Yeah.
can be shown moving towards any of the carbons. Yeah. But
Yes.
if it is a double bond oxygen or a triple bond oxygen or double bond nitrogen, supposedly like this also for a moment, then the pi electrons will move to more electronegative atom in the bonded atom always. So here the electrons, the pi electrons will move to this oxygen, and this pi electron will move to nitrogen. As a result, of these two multiple bonds से बंधा हुआ दो atoms हैं, one becomes negative and the other one becomes positive. Say example, carbon double bond oxygen. So it would look somewhat like this: minus and plus.
Okay.
All right. Now I'm not showing rest of the bonds here. It will be like this. All right.
Yeah.
Now, now it depends on the nature of the attacking reagent. What is the attacking reagent? H plus. Then H plus will move towards this oxygen, right?
Okay.
And if it is Cn minus, it will move towards carbon.
Okay.
So depending on which group is the attacking reagent, which atom the attacking reagent is attached, you define minus E effect or plus E effect.
Okay.
All right. Any idea which is a plus E effect here?
Uh, that first one.
First one is plus E effect because it is moving towards, it is getting attached towards where the pi electrons moved. So example, in pi electrons moved towards oxygen, then the attacking group, that is H plus, will attach to the atom to which pi electrons moved. Then it is plus E group, plus E effect.
Okay.
Right? And if Cn is attached, in this case, where would this attach to? Carbon. Here. Why? Because Cn minus cyanide is electron rich and carbon plus is electron deficient. So minus of this and plus of this will be neutralized, and the whole molecule will be left with minus charge. Point number one. Point number two, the Cn attached to the carbon from which electrons moved away. You see before this, right? Pi electrons moved away from carbon. That's why this is minus E effect.
Okay.
Getting the point? Minus E effect. So there are two types of bonds. Now, the moment if you remove the Cn group from here, or if you remove H from here, supposedly from the molecule, what would happen? This carbon would come back. Say example, if you have like this carbon single bond oxygen O minus, and Cn is attached to this because this carbon had plus charge. And suppose you for some reason you remove cyanide, this group, this negative charge will come back to this, and this will again become C double bond O. You're getting a point? So it means that the effect is temporary. As long as you have that external reagent or attacking group present, the pi electrons shift from less to more electronegative atom. The moment attacking group is removed, they retain their original structure. Is that clear now?
Yes.
Yeah. So let's have a look at now here. So electromagnetic effect is defined as the complete transfer of pi electrons. All right, I would say here pi electrons of a multiple bond towards one of the bonded atoms. And which is that bonded atom? The one which is more electronegative.
Okay.
All right, at the demand of an attacking reagent. So it all depends on attacking reagent's nature, whether to be called plus E effect or not. So there are two effects. Plus E when displacement of electrons is away from the atom or group, addition of H plus to alkene or any such, right? And minus E effect when the displacement of electron is towards the atom or group. Now, I hope you understood this much.
Yes.
Okay, let's take an example here. In this case, this is the plus E effect.
Yeah.
All right, and what is happening? Electrons are moving from one carbon to this carbon, not directly to this. All right, so when it moves, this carbon becomes negatively charged and this becomes positive charge.
Okay.
And as soon as you bring H plus, this H plus ka positive charge will obviously attach to this carbon, which is negative, and therefore the molecule will become CH2CH3. All right. Okay, let me give an example here. I may give you one simple question here to understand how we use this. All right, just write down a formula in your notebook. Write this: CH3CHO plus Cn minus. Done that?
Yes.
Okay. Can you tell me how would product look like? I'm not talking about the positive part, but what would be the product like? Suppose this is HCl for a moment. Now tell me, how would product look like?
Like Cn will attach to that carbon group.
Yes. Which carbon? First carbon or second carbon?
Second.
Okay. So I'm calling second because I'm just calling. Indeed, it is the first carbon. You know it. This will be like this. H is already connected to this hydrogen, and O is left with minus if you don't talk about this for a moment. So it can be K plus also, it can be H plus also,
Yes.
it can be anything, right?
Yeah.
So, and the valence. So where is this being directed depends on the movement of electrons. So you just have to show like this. Okay. So what would you like to call it as? Plus E effect or minus E effect?
Minus E.
Minus E, because the electrons actually move towards this, whereas addition has taken on this one.
Yeah.
All right. Okay. That's what electromagnetic effect is about. There is nothing great in this. Let's talk about it. Anything else in electromagnetic effect?
No. I understood.
I'll give example where both the effects can come into play at a time. All right. Supposedly, we'll just talk about first Mesopotamia effect, or it's called also resonance effect, which we have done earlier. All
Yeah.
right. And I told you, how do you know whether the given group which is attached to a benzene ring or any molecule is going to cause minus R effect or plus R effect.
Yes.
All right. So resonance effect is also called mesomeric effect. All
Yeah.
right. Uh, if you remember the example I gave last time, this one,
Yeah. Like you gave see carboxylic acid which is attached to that benzene ring,
yeah,
and
like this, right?
on that para position there was amino group.
Yeah.
In one
Suppose
there
you
was
have
a
amine. Second time I said, supposedly it is uh, NO2. So my question was, how would you know this is electron donating or electron repelling, right?
yeah.
So what did you learn? Like which of these is electron withdrawing group?
That second one.
Yeah, this will withdraw electron. How did you come to know?
Uh,
Because it has,
uh, Basically it has multiple bonds
exactly, it has multiple bonds. And why is this electron repelling group?
because it has lone pair of electrons and
That's why this electron can be moved like this.
yeah.
Correct? All right, good. Now, this is called resonance effect. All right, this is called resonance. So as a result of this, it will create a lot of structures, right? Like this. All right. So electrons will move from here to here, and next time they'll move from here to here, and third time they will move from here to here.
Yeah.
All right. So this causes actually either electron rich site or electron deficient sites on the benzene ring.
Okay.
All right. And same goes for inductive effect. We talked about if you have CH3Cl, CH2Cl, COOH, and the one without Cl. So you have CH3, you H, H, and Cl. So you there have two acids. Which of these two acids is stronger acid? We talked about based on inductive effect. Cactus,
First
remember that? Yes. This one,
no, that one.
this one. Think
Yeah.
this one or this one now.
Hmm. This one which
First
has
it is
CH.
chlorine. Yes,
Hmm.
yes, good. You're right. This will have more effect, right? So we
Yeah.
talked about inductive effect. So you see the effects are similar. What is happening is the electrons being pulled, all right, and in this case, electrons being pulled towards oxygen, but it's resonance because it is giving a lot of structures, different structures, and because of this inductive effect, we have seen you can decide whether the molecule will be acidic or basic kind of stuff,
Yeah.
right? And so they sound very similar to each other. That's there in the organic chemistry. Now, a resonance effect is similar to what we discussed in this case, right? Whether it's
Yeah.
going to be electron rich or electron withdrawing, we'll decide. So let's have a look at quickly what is resonance effect first. So which is also called Mesopotamia effect.
Yeah.
It is a flow of electrons from one part of a conjugated system to the other cause to the other, caused because of phenomena called resonance. So what are conjugated systems?
Like which has uh, the system which contains more compounds or
Oh, okay, let me clarify. If a molecule has got alternating single bond, single double, all right. Like you see in the case of benzene, the
yeah.
first two carbons, suppose you make double bond, so next two carbons make single bond,
Yeah.
right? So these are called conjugated systems.
Oh.
Okay, so if you have a conjugated system, remember that these electrons which we are talking about, we are not categorically mentioned pi electron. If you remember the last case, I had mentioned pi electrons. I
Yes.
made this correction. But here I am not saying pi electrons because these electrons which we are talking about may not be pi electrons. All right. So when you are first time introduced resonance in the class, perhaps you were given the example of structure of benzene,
Yeah.
right? And you are shown key why benzene has got more than benzene can be depicted by more than one structure, and they call this is called resonance. So it
Yes.
means that you were given clear only benzene molecule. It was not a substituted benzene. So it means that molecule need not to have a functional group or a
Okay.
substituent, right?
Yes.
Without having it also can show. Let's take an example of. Can you write one structure in a notebook and let me know what have you written in the sequence? One three, sorry one three butadiene.
So I have to draw it.
You draw and you have to read the way you have written, okay? Along with a double single bond.
Okay.
1,3-butadiene. Maybe I'm not drinking water. మండుతోంది ఇంకా. Done, beta?
Yes.
Now you have to read for me.
Uh,
Little faster.
like how should I read?
Like you said, CH single bond, CH double bond, single bond, whatever.
So first, CH will have double bond. I mean,
Okay.
like there are 4 carbons. So the carbon which is at the first
You
position.
tell. You tell me carbon single bond, carbon single bond, carbon type. Forget about
Carbon.
hydrogens.
So carbon double bond, carbon single bond, carbon double bond, and then carbon.
Correct. Right. So what do you say here? Alternate double bond and single bond are alternating positions or not?
Yes.
So would you like to call it a conjugated system?
Yeah.
Yes. So these are diene compounds. Diene, ene, double bond, right?
Okay.
The example of diene. Even if you do not have nitro group or amino group or hydroxyl or anything, still the pi electron can shift. All right. Do you think you can show resonating structure of this molecule?
Sorry.
Can you draw resonating structure of this molecule?
Yeah.
Try. Are you seeing at the screen also?
Yes.
Would it be somewhat like this?
Yes.
So how would you move the electrons?
Like I will like the carbon which is on the second position. So we can move.
Where would electron move first?
Yeah.
This will move to?
Next carbon.
Okay. What do you get after that?
Then like there will be a negative charge.
Okay. And first carbon?
That will have positive.
Okay. What is the next move? You may have this moving this side.
Yes.
Right. And the negative charge that you have brought here can move this side.
Yeah.
Do you think it will move this side or it will go back?
Sorry.
It will go back. Because first it will go back because the first carbon has become electron deficient. All right. So two adjacent carbon cannot become electron deficient. Am I right? Say example, if you move this, you may have written like this, right? Double bond, like this. So if you have moved this to this already became plus.
Yeah.
And this became negative.
Yeah.
And this is anyway minus double bond this. All right. Now if you move this towards this side so that this can move this side, so what would happen? This cannot pull the electron further from here because this is sigma bond.
Yeah.
So what happens? This is anyway positive and this also became positive. Sorry, this become double bond. Sorry, this negative charge is come here, and this carbon, and this becomes single bond, and this becomes negative.
Okay.
I hope it is clear now.
Yes.
All right. So in case butadiene, all right, is to be affected, is to be be attacked by H plus Cn minus, that is HCl. So which all carbons can hydrogen go?
Uh, like the one, like the one.
Second,
Huh?
left to right, first or second, third, ऐसे बोलो.
Okay. So from left to right, second carbon,
Second carbon
or that fourth carbon.
fourth carbon. And Cn can always attack either at
First carbon or the third one.
third. Do you think it will attack at third carbon?
Yeah, third.
Hmm. Why?
Uh, because of that, because it is electron.
Okay,
Yeah,
this electron move. Sorry. Well, carry on, beta.
because it like the bond pair which was shifted from second carbon to that third one, so it will attain a positive charge.
Cn minus will attack at this point, but H plus can attack either this carbon or this carbon,
Yeah.
right? So, because don't forget that we have hydrogens also already connected, which we have not depicted here. So, you do not have to have NO2 or NH2 or OH, etc. in the molecule, all right, to see the shifting of these electrons, all right. Doesn't it look more like an electromagnetic effect?
Yes.
Yeah, so there's a very slight difference in this. The moment I say that, now my question is that if you simply draw this molecule, double bond, the one you had drawn originally, single, and then again double, right? And there is no functional group is also present in them. Am I right?
Yes.
There is no functional group present in this. Why would pi electrons move? They have no motivation to move, right? So the only thing you can perhaps rewrite this. I'll just try this for a moment. Like say this is cyclobutadiene.
Okay.
All right, like this.
Yeah.
All right. Okay. Do you think these two pi electrons here? Do you think your pi electrons can move without having any group coming to attack them? Yes, they can.
Yeah.
You can write like this.
Yeah.
So this is happening on its own, and it is interconvertible, radially interconvertible, and therefore it is a mesomeric effect or resonance effect.
Okay.
But if this change is happening, coming positive or negative, it's become positive or negative here, because a group is coming to attack them, then it is called electromagnetic effect.
Okay.
Okay. Now coming down to resonance effect quickly. Right. So you see there are two what you call mesomeric effect or resonance effect. It's called minus R or plus R when the electron displacement is towards the group. The same thing. All right. Now, if suppose you have already group present in the molecule and it is happening, the electrons are moving towards, all right, where you have the substituent group or functional group present already, then it is called minus R.
Okay.
All right. We have done this, I believe. And you know the reason why this will show minus R effect, because it has multiple bonds. It has multiple bonds. About in plus M or plus R effect, the electron displacement is moving away from the group. So जब move away हो रहा है, इसका मतलब ये है they are already electron rich.
Yeah.
Okay. Electron richness in the form of lone pair of electron, right? Okay. Let's have a look at now quickly electromagnetic effect. You have seen already talked about. I did not put them in order. First one is and second one. I've written anyway. Shifting of electrons in electromagnetic effect. All right. What is shown there? Look at the. Can you tell me the difference between the two? What do you call changes? Why first is correct but not the second one?
Yeah, because that bond pair is shifted towards that first carbon
CH2.
from the right side. Yeah, CH2.
Correct.
And
Okay. But why not the second one?
like because of hydrogen because hydrogen which is attached to that first carbon is uh, like that two carbons, two hydrogen only.
Hmm. All right, let's have a look at this first. And the both formula on the left side are correct. Same, sorry. CH3, CH double bond CH2, right? Both are same formula. Now, why first one is happening but not the second one? Look at why should electron move towards CH2? In other words, why not move away from CH2, like in the second case? First one is moving towards the CH2, like the pi bond, because CH3 on the leftmost, this electron repelling group,
Oh,
right? And it is not present as a substituent, it is a part of the molecule.
oh.
You're getting my point? So
Hmm.
you have to be careful. Even suppose there is no substituent, you should know which direction can electrons move. When you have NO2 or NH2, you know how to move.
Yeah.
All right. But even if you don't have them, you should know which direction would electrons move. All right. I want you to make one correction in the first box on the right side. I want you to make one correction in the structure given in the first box, which is in bracketed by red color. In this case, I want you to tell me one suggestion, one mistake which is to be corrected.
Like it will be CH3 and like on the carbon which has gone there.
The first one you're talking on this case, right?
Yeah.
Okay, this side is fine. This is the original molecule.
Yeah.
Would like to suggest any changes in this?
Yes. It like the one carbon which has lone pair of electrons. It will be CH3.
Why CH3? Hydrogen did not move. Hydrogen did not move. Only electrons moved. Pi electrons. So why would it be CH3? All right. How many electron pairs were there between these two carbons?
2.
1, 2 pairs. Out of these 2 pairs, okay, 2 electrons from this carbon, 2 electrons from this carbon, right? And after the shifting, the entire one bond shifted to this carbon. So out of these 2 electrons, which were like this bond, all right, one electron was originally of this carbon, but the extra electron has come from this carbon, second carbon.
Yeah.
So it has lost its electron and it has gained an extra electron, right?
Yeah.
So this is originally of this carbon, and this was actually the electron originally of this carbon has moved to this carbon. Should not this have acquired a negative charge?
Yeah.
You see this case. All right. So you make sure that you mention that. Okay. So just because you don't write this, you may commit mistakes for this. All right. So I've given you this now. Now just write down one formula. What I'm asking you to. Draw the benzene ring.
Yes.
Okay. Now draw amino group on top. Right. And now make nitro, para, ortho nitro, aniline, like this, right?
Okay. Well, like
And similarly make,
nitro group should be present in ortho position.
yes, now nitro must be in ortho position. Meta, done, and para. Done?
Yes.
Okay. Will this compound be able to show plus R effect or minus R effect, whatever is correct? Do you think this compound can show plus R or minus R effect?
Which one?
All these same compound? No. Yes or no? Faster. It's as simple as to tell answer. Will this compound be able to show resonance or not?
No.
Why not? Does not it
Like
have
electron
substituent?
drawing group and one is electron donating.
So what? They won't cancel out each other's characteristics, right?
Yeah, but
Right. Now my question is that will this compound be able to show plus R effect, minus R effect, whatever? Yes or no? Will it show resonance or not? Just now you answered. Yes?
yeah, maybe.
Not maybe. They will show.
Okay.
Why? Okay, I'm just drawing this much. Draw formula of aniline.
Yes.
Right? Okay. So what is present in place of this? This carbon is attached to what here?
NO2.
Is molecule.
Oh, English only.
H.
Yeah.
There's nothing means H. And in this case also it was connected to H earlier
Yeah.
originally. And in this case also carbon is attached to hydrogen. Alright. So you have substituted this hydrogen by NO2 group. You see that, right?
Okay.
Is this clear now?
Yes.
Okay. Now among these three things, they will show R effect. All these molecules will show resonance or plus R, minus R, whatever we talk about it.
Okay.
My next question is that will it show plus effect or minus effect? And don't take much time I know that thinking should be allowed. In IB we say we should allow students to think and answer, but this is different. I'll just wash my hand because I've had okay, meantime quickly think and answer. Yes, you got the answer?
Maybe minus R.
Okay, why minus R? Okay, what is the original functional group in this molecule? This compound is a derivative of what? What is the name of this compound? Yes, you're right.
This is
It is
all.
You're right. It is a compound of aniline,
Yeah.
not compound of nitro. Agreed?
Yeah.
So, what is the main functional group present here according to you now? Amine.
Amine.
So, it is the amine which is going to determine primarily the characteristics of this molecule.
Yes.
So, what is the nature of amine? It is an electron repelling or electron withdrawing?
Repelling.
Yes, electron repelling group. Good. So, if the electron is repelling, okay, this is the lone pair of electrons, right? This is a lone pair of electrons. So when it is repelling the electron, it will go here.
Yes.
In other words, it will go here.
Yeah.
Right? So where would the first negative charge come?
The one which has a pencil point.
Yeah, right?
Yeah.
And where is the next electron richness?
On
Yeah.
that. Yeah, below. Yeah.
Yeah. And where is the next electron richness?
NO2 near N.
Yeah. So it's basically ortho position and para position.
Yeah.
Getting now point?
Yeah.
Now, what is the nature of NO2 originally, wherever it is present? Electron withdrawing group?
Yeah.
Because the multiple bond, right?
Yeah.
Now, nitro is withdrawing the electron, but the lone pair of electrons are shifting from ortho to para to meta.
Yeah.
Right? So, in this case, the electron urge of nitro is fulfilled best.
Sorry. The voice was not
So,
clear.
I repeat once again. Amines lone pair of electrons are moving from ortho and then to para and then to ortho again.
Yeah.
Right?
Yes.
But they're not going to meta position. Agreed?
Yes.
Okay. So in which of these three cases electrons are reaching out to nitro, because nitro and NO2 is pulling the electrons.
Yeah.
So in which case the nitro's electron urge requirement is being fulfilled because of amine, the one which is present in ortho para or the one which is present in meta?
The one which is present at ortho
Ortho and
para position.
yeah, because electrons are reaching to ortho and para both.
Yeah.
Amines lone pair of electrons reaching to ortho position as well as para position.
Yeah.
Therefore, the one with the molecules in which nitro is present in ortho position or meta position, sorry, ortho or para position,
Yeah.
the electron urge or electron deficiency is fulfilled because of amine group present on top.
Yes.
So, which group? So it means that they don't seek for electron as much as the one seeks in being in meta position.
Yeah.
Because in meta position, the electrons are not even reaching them.
Yeah.
So it means that which of these three structure has the highest urge towards keeping the electrons or pulling the electrons from outside source. Say example, you have an electron rich site, say example, chloride is there, supposedly.
Okay.
All right. So which of these three nitros, NO2s, ortho, meta or para, which of these three nitro will show maximum interest in this Cl minus? I'm just giving example Cl minus, it could be something which is feasible. Yeah.
Third one.
Which of these para?
Yeah, because
Acha, at which position nitro's electron desire is getting fulfilled? Is it getting fulfilled in this case? Yes or no?
yes.
Okay. Is it getting fulfilled in para position because of amine group?
Yes.
Is it getting fulfilled in case of this NO2?
No.
No. It means that which nitro is seeking for the electron most?
So that
Meta.
yeah. Second.
Right? So imagine that this electron from amine is moving from this to this to this.
Yeah.
But here you have NO2. Actually, my pad is troubling me out. I don't know why. This NO2 is like this. Right?
Yes.
But this load pair of electron from amine is not reaching to here, so that this nitrogen could be happy of nitro. So the moment these three molecules come in contact with anything which has got Cl minus or electron rich, so where would this electron rich attacking group attack at? To this nitro or to this nitro or to this, sorry, this nitro or this nitro or this nitro?
Ortho.
Achha, theek hai. I'll just try explaining once again. You are confused?
Yeah, little.
Okay, do one thing. You just draw all three nitro compound.
Okay.
Say on one below another. Done?
Yeah.
Okay. Show nitro like this in your group, all groups.
Okay.
So nitro you always show like this, okay?
Yes.
Now have you made ortho,
Yeah.
para
Yeah.
and meta?
Yeah.
Okay. Now tell me where are these? Now you have to show that only negative charge, okay, which is moving because of amines nitrogen. Let me show one example so that okay, let me show here. So I'm showing this amines nitrogen is going to ortho position. So this carbon is becoming rich, electron rich.
Yes.
Similarly, you show for, I have drawn both ortho. All right. Similarly, you show for meta, para,
Yes.
and same thing you show for meta also. All right, done.
Yes.
Okay, in which case the electrons are nitrogen is electron urge. This nitrogen of nitro group, this nitrogen of nitro is always positive charge.
Yes.
Okay, so in which case the electrons from amine are farthest from n plus of nitro. Ortho, para or meta?
From amine group.
Amine groups electrons, look at the screen please. This amine group's lone pair of electrons are moving to ortho.
Hmm.
It means they are coming to this carbon,
Yes.
right? And next time they are going to this carbon, which is para.
Yeah.
And then again they are going to nitro ortho position.
Yes.
So when the negative charge is here, and negative charge is here, and negative charge is here. So in which case the nitrogen of nitro group, this is the nitrogen of nitro group, which is carrying positive charge. So which of the nitro group is farthest from negative charge? Ortho nitro are farther from the negative charge, or para nitrogen are farther from negative charge, or meta nitros are farthest from negative charge.
Meta.
Okay, so among these three now, which nitro would seek for negative charge most strongly? Ortho or
Meta.
para or meta?
Meta.
It means that meta nitro group is seeking for negative charge, is ready to accept lone pair of electron or negative charge most strongly. Agreed?
Yeah.
So which is the strongest base?
Meta.
Ortho, meta, correct. Meta will be strongest base.
Yeah.
All right. So this is how you have to understand. If you have a group present where the resonance is also shown, mind this, what I'm saying. You have resonance is also present, and electromagnetic effect is also likely to happen. Now chloride is going to attack.
Okay.
Right. So
Yeah.
which is playing more important, which is deciding where will this chloride go? Electromagnetic effect is deciding, or resonance effect is deciding where is this chloride going to?
Resonance effect.
Exactly. So make a point. If you have possibility of resonance effect also happening within the molecule, and electromagnetic also, a resonance effect or mesomagnetic effect will have greater role to play. You getting my point now?
Yeah. Can you repeat that last word you said?
I said that within a molecule, there is a possibility of exhibition of mesomeric effect as well as electromeric effect. The resonance effect will determine the direction of chemical reaction.
Okay.
Is this clear now?
Yeah.
Alright, so this is how you can understand what is important, but this is self-understood. But what you do, you always know that is happening because of resonance. You voluntarily said, and without taking time, you said that is because of resonance. The meta position is attached to chloride. Suppose it is chloride. So you understood it is resonance which is deciding what will be the direction of reaction. So electromagnetic effect is also going to happen in the molecule.
Okay.
Still, वहाँ कहाँ पर electromagnetic effect होगा, वो decide करने वाला है resonance. So if you come across both, rely more on resonance effect or mesomeric effect than on electromagnetic effect. Okay, so don't simply say अगर देख लिए अमाइन और नाइट्रो ग्रुप साइड बाय साइड देख लिए, हाँ ये तो ऑर्थो में अटैच हो जाएगा, ऐसे नहीं देखना है. You have to see कि रेजोनेंस के कारण कहाँ पे इलेक्ट्रॉन रिच साइट और इलेक्ट्रॉन डिफिशिएंट साइट आएगा.
Yeah, I
All right,
got.
and then you decide. All right, okay. So this is how you understand the importance of uh, acidic strength or basic strength of a compound. I hope I could clarify the application of this. Okay, now write quickly one equation and then I'll write one equation, please. Uh, sorry. Acetone का formula लिखो. Structure CH3 single bond C double bond O CH3, right?
Yeah.
Okay, now plus write down. Um, uh, say Caesian. Caesian. Okay. Now tell me where would see K is not important in organic chemistry. All right. It is a OH group which is more important because its attachment decides properties. Now, where would OH go to? And what will be the product? If not the final product, byproduct. Because there are certain other molecules also which participate. So I've given only one KOH to simplify. So where would OH minus go to in acetone?
Like, how should I tell?
I can write down the equation between these two. Suppose you have only acetone plus OH minus. Now write down the product.
Okay, it's not casein, it's OH minus.
I said Caesian, right? Caesian. Then take Cn minus.
So, I have to tell where Cn will go.
Yes, I want the position of cyano in the molecule and the product molecule.
So, Cn will go to that carbon, like the carbon which is after CH3, to which oxygen is attached.
Okay. Okay, I'm just writing here, okay? Just have a look at here. This CH3, C, double bond O, CH3. And you said OH. So this is going to this carbon?
Yeah.
Alright, good. We go to this Cn because this will be minus, and what will be left molecule with? Just minus.
Minus.
Right? So any cation which is present here, it could be any cation that would come to this point.
Oh.
You getting my point?
Yes.
So the reaction takes place in aqueous medium mostly. So H plus would automatically come to this.
Okay.
I hope you understood.
Yes.
Right. That's what the brief. I wouldn't say brief because if you explore about electromagnetic effect, you don't get much. But resonance effect, yes, we discussed last time, and partially inductive along with the inductive effect, and bit not this time also. Tell me now, if you are given a molecule, you can predict whether the molecule which will be more acidic, less acidic, etc. kind of stuff, or basic.
Yeah.
Okay, so that's what the usefulness of knowing resonance and resonance effect. Sorry.
Yes.
All right, now molecule. So you have any questions that you wish to discuss?
No, actually, I understood.
You understood. So I would suggest if you have a soft copy of any paper, all right, because I have not been dealing with CBSE for past since 2006, to be honest. Since 2006, I've stopped teaching CBSE. So if you could tell me if you have any soft copies of questions which you would like me to sit and discuss with you, I would be more than happy to discuss on this. Or else you give me a subtopic, that topic that you gave like today. I'll be prepared for the same topic next time.
Okay. Yeah, I have one question. Like, where we use electromagnetic effect?
Electromagnetic effect is now, if you look at the one second, give an example. if you have studied the properties of ketones and aldehydes,
Yes.
all right, if you look at their properties are very similar because both of them got C double bond O,
Hmm.
right? If they have C double bond O, it means that they, in order to explain what will be the product, like the one just now I gave, you remember the example of formation of cyanohydrine?
Uh, yeah. Pretty good.
That, yeah, the structure which I drew here just now, CN attached to uh, carbon and H attached to
Yeah.
what you call O, that is
Yeah.
an example of cyanohydrin. So what will be the product formation that you can guess from that electromagnetic effect? But as I said that if you have resonance effect and you have to talk about inductive effect, you have to talk about electromagnetic effect.
Yeah.
What plays key role is basically resonance effect and inductive effect, much more than electromagnetic effect does ever.
Yeah.
So electromagnetic effect, that is the reason why most of the people discuss very little about electromagnetic effect,
Hmm.
and they just say that in case you have this group, then they behave. So what will be the product like? So it actually, in the electromagnetic effect will decide, help you when there is no resonance happening, and you have brought an attacking reagent close to a reacting molecule, and you have to predict the product, and which is actually simple. So pi electron will move to one of the carbons or one
Yeah.
of the atoms, I would say, जिसके तरफ मूव करेगा वहां पे नेगेटिव आयन आ जाएगा, जिस तरफ से मूव हो चुका है उस पे नेगेटिव, सॉरी पॉजिटिव आ जाएगा, देन नेगेटिव आ जाता है। वो प्रोडक्ट क्या बनता है बता देता है, लेकिन इन सिंपल केमिकल रिएक्शन। बट इफ यू लुक एट फ्रॉम कॉम्प्लेक्स पॉइंट ऑफ कॉम्प्लेक्स रिएक्शंस, resonance effect will play a major role.
Yeah.
Indeed, everywhere it becomes more dominating,
Yeah.
resonance effect,
So
right?
basically, resonance and inductive effect both play major role.
इंडक्टिव इफेक्ट का यूजुअली जो केस ना वहां बनता है जहां पे यू हैव ओपन चेन कंपाउंड्स,
Okay. Yeah.
right. But if you look at the benzene and anything related to benzene, substituted benzene or aniline or nitro compounds, nitrobenzene, yeah, the functional group बता देगा कि भाई मैं यहाँ पे इलेक्ट्रॉन रिचनेस क्रिएट कर रहा हूँ या इलेक्ट्रॉन डिफिशिएंसी, या ये बता देगा कि existing group, like say example you have only amine for a moment, all right, and it's an aniline compound, and you have a group called, say example, HNO4,
Okay.
all right. So you'll be asked what will be the product. You getting my point? So ध्यान देना मैं क्या बोल रहा हूँ. Should I write on the screen once again?
Yeah.
I'll just take 2 minutes. Okay. So if you have amine group in the benzene ring, right, and you have it is undergoing what you call nitration,
Yeah.
HNO3 plus H2SO4, right? Nitration is happening. So this actually breaks into OH minus and NO2 plus,
Okay.
right? NO2 becomes plus. The oxygen is more electronegative, so it keeps the electron and makes NO2 positive. Now, where would this NO2 plus go on this benzene ring? All right, this is the attacking group is known to you now. What problem that you may have to think is that, sir, attacking group आ रहा है तो क्या ये electromagnetic effect show करेगा? First question, मैं बोला था थोड़ी देर पहले, ये conjugate system है, double bond, single bond, double bond, right? तो मैं सब कुछ वैसे लग रहा है जैसे कि electromagnetic effect में बताया था, लेकिन you should not get confused because you know that the double bond, single bond conjugate system is fine, presence of attacking group is fine, but the molecule, original reactant molecule that you've taken is capable of exhibiting resonance.
Yes.
NH2 group, right? इसलिए resonance को ज़्यादा ध्यान देना है. Point number 1. Point number 2. अब resonance पता चल गया तो ये देखना पड़ेगा कि ये जो existing group है is electron withdrawing or electron repelling. Third point. If you identified that, you have to see where will these electrons move to.
Ortho and para.
हाँ, ऑर्थो एंड पैरा में इलेक्ट्रॉन रिचनेस क्रिएट करेगा, तो ऑब्वियसली जो केटायन है या बोलना चाहिए इलेक्ट्रॉन डेफिशिएंट मॉलिक्यूल है, वो इलेक्ट्रॉन रिच साइड को ही अटैक करेगा, ऑर्थो बनेगा और पैरा बनेगा.
पैरा को करेगा.
इतना क्लियर हो गया पहले? दूसरा बोलते हैं कभी-कभी you must have seen that usually whenever a compound forms I'm not sure because I have not taught it for long. So ये say that ortho जो है 60% बनता है और ये 40% बनता है.
Yeah.
क्या है ऐसे यार है ना. तो ये 60% में 40% बनना किस बात पे डिपेंड करता
So,
है? It
like we
depends.
say that the major product is formed when the group is present on para position.
पैरा पोजीशन क्या?
Yeah.
अच्छा मेरे को ऐसा याद है कि ऑर्थो पोजीशन पे है.
Like in like the this last chapters of 12 was organic only. So in that there
अच्छा
were two products, ortho and para position पे थे वो. So para position
ओके
का major कहते थे mostly like 90% of the case.
ओके पुश.
Papa. वो सर की क्लास में बैटरी लो हो गई थी.
आपकी
नहीं सर की.
हेलो.
कर लेंगे क्या?
हाँ sorry the laptop battery drained out. Yeah. So the formation of the product, I mean, the stability of a compound, it depends on primarily whether these electrons are. I just remind you one thing. Do you remember the polarity of the compounds?
Yes.
All right. What happens like if you have polarity in the same direction, so obviously it will create some kind of positive negative charge. Like for example, you have a polarity. I'll just share the screen once. I will just take few more minutes so that. If you have a polarity like this, here in this direction, here is in this direction, and here is in this direction. All right. So in this case, polarity will get counterbalanced, right?
Yes.
And the molecule will have neutral charge, no charge. All right.
Yeah.
But so molecules in organic chemistry with neutral charge, okay, is more stable.
Okay.
So if you have molecule here on the ortho position, para position to each other, which are creating polarity in the opposite direction, it is likely to be more stable.
Yes.
All right, it's just not para all the time. It can be ortho also, which can be a major product. If you look at some examples.
Yeah.
All right, but in case of ortho and meta, the molecule will always have some degree of polarity.
Ortho.
That's why they are relatively lesser stable, and that's what you said. Para compounds are found to be usually more stable.
Yeah.
All right. So this is the basic reason. So may I end up the class? Or you have any doubts?
No, I'm not having it.
Okay. Just drop me any questions that you have. List of questions so we can discuss in the next time. All right. And I'll try my best to spare some time to solve them first before coming to the class.
Okay.
All right. And I hope now what you do, you pick up some examples from book. Just look at the structures and draw the resulting structures and predict whether it's more acidic, less acidic. In case this reacts with XYZ, what is the product it is likely to form. make these kind of predictions, because this 1 hour, half an hour class may not really, teach you that much,
Hmm.
but unless you practice something based on this.
Yes.
Okay, so please practice something, so it'll help you. Okay,
So from
fine.
next, I guess
Yeah.
this topic is over, or there's something left in it.
As far as electromagnetic and resonance effect is there, you can talk a lot about resonance. All right.
Yeah,
Like as far as you pick up example of X, Y, 10 examples, you take 10 lessons.
yeah,
So that's what I'm saying, that I'm giving you the overview of the concept and the skill that you require to draw the structures and predict what will be the product. So you take some examples and practice. All right. So you know that yes, I'm thorough with this concept.
yeah,
Getting my point? Because it's very it's happening on virtual platforms, so a lot of things may not happen
yeah.
on such. Okay, so in case you have doubts, still feel free to drop me questions.
Okay. So I will send you the
Okay,
question.
okay, let me
Right.
know. Yes, yes, you can mail me. Okay, I'll send you the solution possibly as early as I can, because I'm doing some online marking also, which is IB marking, and we have a target to finish 100 papers in next 20 days. So on
Hmm.
an average, 5 papers on that day, and every paper takes minimum 1 hour,
Okay.
minimum marking. So I'm spending anyway 5 hours only on marking.
Okay.
So I'll definitely find time and answer to your questions before you come to the next class.
Okay. So
Bye.
thank
Bye.
you, sir.
Yeah, okay. Thank you. Bye.